I have this little power supply powered up, and the meter is connected to the red lead, which is now connected to the output, and it goes from 30 volts down. There's no load on it, and there is a filter capacitor across the output, so I have to go slowly. And this is millivolts, so practically nothing, the whole way up to 30, just exactly as is advertised. I'm powering it with a 24 volt 5 amp transformer, and right now that transformer's outputting at no load 26 volts, so almost 27 volts. So it's 3 volts higher than specified. But this is a really heavy-duty, American-made transformer. I'm sure that when we draw 5 amps, it'll produce 24 volts. In any event, there will be a time when you operate this power supply with no load or very light load. The 24 volts, in this case 27 right now, is rectified, filtered by these filter capacitors, and reads 35 volts, 35, almost 36 volts. Now this is not a 24 volt Chinese transformer that might have an open circuit voltage of 32 or 33 volts. We're supplying it with 27 volts, and we have a rectified power of almost 36 volts. The 27 volts passes through a bridge rectifier, series of filter capacitors, and there's DC here. The negative side of the bridge rectifier comes down here and forms the negative rail of the power supply. So right now we have almost 36 volts between here and here. These two integrated circuits take their positive power from the positive power rail and their negative supply from the minus 5.1 volt rail. So right now these are receiving 41 volts. Well, they're only rated for 40 volts. So right now we're exceeding the rating of these two devices. Now let's look at what happens when we reduce the output voltage. Remember, this upper rail is sitting at 30 volts or more. The reduction up from 30 volts to 0 to 30, or 34 volts to 0 to 30, occurs in these two transistors right here. They're Darlington connected, essentially an emitter follower. Whatever voltage is present here, or here rather, since they're a Darlington pair, is presented here. Now let's say we want 30 volts and, well, let's say we want 25 volts out. We have 35 volts here. And let's draw 5 amps. That means we're reducing this 35 volts to 25 volts here. That's a 10 volt loss between here and here at 5 amps. That means these two devices, mostly this Q1, are dissipating 50 watts. The tip 3055 looks good, 15 amps, 60 volts. We're not exceeding either of them. Here's the rating that matters, 90 watts. So we're forced to operate in this safe area here. If our emitter to collector voltage is 10 volts, which is what I'm using in my example, and we have 5 amps flowing, it puts us right here, inside the envelope, but close to it. If I decide to decrease the output voltage from 25 to 15, now we're going to drop 20 volts across here, 35 to 15, at 5 amps. Well, we're still on this 5 amp line. We run out of the safe area right around 15 volts. We can't drop 20 volts at 5 amps. If we wanted to drop it clear down to 5 volts at 5 amps, that would be 30 volts drop across Q1, or Q1 and Q2, however you look at it. 30 volts at 5 amps is 150 watts. Well, that's nowhere near the capability of the tip 3055. We could put a little chart on the front of the power supply that says, it gives a graph of the allowable output voltage versus amps. That's not a very good idea for a general use power supply. So this is a very common problem to run into. The 30 volt 3 amp supply that's ubiquitous on the Chinese market. You can buy them, the circuit board, the potentiometers, and all the components for less than $10. You're trapped like this. Now, this imaginary 90 watt dissipation limit assumes that temperature here can be kept down by this fan and heatsink. If we allow this temperature to go up to 100 degrees C, because it decreases 0.72 watts per degree, pretty quickly we go from 90 watts to 30 watts. Now that's at 100 degrees C, but it's very possible to run this at 60 degrees C, in which case you'd replace this 75 with 60 and you get some number, but it's not near 90 watts. Most people, if they do the calculation, will either provide a smaller transformer, that is, smaller in less amps or less output. Now, it'd be nice to use the full range of these potentiometers. And as you saw with my introduction, cranking this the whole way up raised the voltage to 30 volts.